Hey everybody, I guess you can see me and you can hear me. This is the webinar 46. Let's check that you can actually see and hear me. The last time we had problems with the sound. There was some noise, and I guess that it has to be fixed now. So anyway, anyone just drop me a message confirming that you can see my face and you can hear my voice. Anybody? So the webinar will be actually about XML today, Java and XML. So, anyone, you there? Just drop me a message. Let me check who's in the chat. Okay, so let's start. I think I can pretty much confirm that we're online. So the webinar will be about Java and XML, and I will explain to you the tool which I created 6 years ago. Actually, I just checked the repository, and it looks like it's 6 years old library, which is used by, I use it, in my projects, in my Java projects, almost in all of them. And I think you should do that too. That's why I decided to record that. It's not directly connected to object-oriented programming, but it's about good programming. I think the library actually makes a lot of sense and really improves the life of Java developers who have to deal with XML documents. And so the webinar will take less than an hour. I'll show you, first of all, explain what XML is and why it's such a beautiful format for data manipulation, transferring, and storage, and compare it with JSON a little bit, just a few minutes. Then I will show you how the tool works, and I will demonstrate the key what they call directives, which are just key commands which this tool introduces or makes available for a Java developer. And then at the end of the webinar, I'll show you the practical use of this library in one of the projects, which also about 6 years old or maybe even older, a Java one, where this tool is actually used. So first of all, a few words about XML. The XML, as you probably know, is a format of data. It was introduced many years ago, and basically the XML document looks like something like this. Books, for example, we need a collection of books, so we say we have a book. I think we need a book, and then the title, object thinking, for example, and then we close the tag book and we close the books. I don't know, it gives it in red. So the XML is, you understand what I mean. So the XML is the way we present data, and we mix data and metadata. So we mix the information about the data together with the data. Object thinking is the data, and meta information is the information about the data, like the name of the element, which is book, the name of another element, which is books, and it's very hierarchical. The XML is a very hierarchical structure. So at the top of the document always stays the root element, the document element, the highest level document, the highest level element, which is books in our case. And then all other elements, they go to the bottom hierarchically. So every element has a parent. So this element has a parent, books, and only the top element doesn't have the parent, meaning that's the highest level element. And also there are attributes. So basically there are elements and attributes, just two things in XML document. Books, for example, book, and then we can say ID equals to 1. So that's pretty much it. That's pretty much all you need to know about XML documents. Well, there are some other things there, for example, namespaces. That's also one thing which may be helpful, but we're not going to discuss that here. The problem with this, again, let me compare it with JSON. You know that JSON is quite popular as well now, and many programmers think that JSON is a better format for data storage and for data transferring because it's easy, because it's simpler, because it's easier to understand for some of them, and it is easier because first of all it doesn't have attributes. So JSON just has elements. Elements, parent elements, also very hierarchical. So in JSON you also have a parent element, and then it goes down to other elements, and then you may have arrays as well. In XML you don't have arrays. In JSON you may have elements, and you may have arrays, but you don't have any namespaces in JSON. Those are key differences. And I wrote a blog post about 4 years ago where I attempted to compare XML with JSON. I was claiming that there are two different things of a different caliber, of a different scale. So JSON is quite primitive and pretty good for really simple use. When you need something small, more compact, more lightweight, that's where you need JSON. For example, you need to transfer some piece of data, a really small piece of data, just a few blocks of data, for example, from for example client side to the server side. That's where I think JSON was created for. Then you use JSON because it's quite primitive. But if you want something larger, if you want something which is going to stay for longer, live longer, like not a few milliseconds but a few minutes or maybe a few days or a few years, like in a database, for example, on some file system, then I would prefer XML. I think XML is more suitable for that use cases because XML is way more powerful, it's way more expressive, and you can maintain it better. You read the blog post. This webinar is not about this comparison. I'm just saying, how much I love XML, and I highly recommend to read the book. I'm gonna give you the link to the book below the video, which is a really great book about XML. It helped me a lot. I read it many years ago when I was starting to take XML seriously, and I read that book and it did help me a lot. So I basically understood the core concepts about namespaces as well, about the structure of the XML, about the fundamental principles and concepts of XML. So definitely read the book. So now back to the libraries. The main question in Java, the main problem for me, it was for years, is how difficult it is in Java. How many lines of code you have to write in order to create an XML document in Java. There is a native library in Java which is based on which is a DOM library. There's a thing on Java, not only in Java but in XML actually, which is called DOM, Domain Object Model. So DOM is a set of interfaces, I would call protocols, interfaces, and then methods attached to it, which were invented in order to tell programmers in all different languages how to create a library to manipulate the XML. So you can find PHP, and there will be DOM. So you will find DOM interfaces there, and you will know how to manipulate XML. You can use Java. You will also find DOM methods and DOM, everything which needs to be. For example, here's how DOM works. So let's say you want to create a document. So here, this is how you start. You call this is very Java specific. Document builder factory. Then you make a new instance of some factory, and then you create new document builder, then new document, and then in this DOM you can actually add a node. So let's see how it's done there. I think it's done. Something like that you have to do in order to create a document. So that was the DOM, and then you create an element, books, and then on top of this, and then you do it like this. Yeah, this is how you create a simple document, which in the end will look like this. So you see, there are 3 lines of code, pretty complex and messy, if you ask me. It looks like too much for me. And then if you want to add more documents, more elements to the document, you have to create, let's say we want to add a book, so that we create a book element. And then we do it like this, book element, and then we append, let's call this one books, and that's going to be books. and then we say books, append book. And this code will create something like this. It looks like overkill to me, if you ask me. Like if I have to write 6 lines of code just to create a simple XML document of that size, then most probably I'm not going to use XML at all. That's why most probably I'm going to use JSON, because even in Java, the JSON library is more compact, and because it's younger, because it was created way after DOM. So maybe that's why JSON manipulations are easier in Java. Also not really beautiful. Also that takes, some lines of code to create a JSON document. But it is Java. In Java, many things are too verbose, require too many lines of code. So I was thinking for years, like how to overcome that, how to do it better. And I tried different libraries, because there are libraries which replace DOM, which claim to be better than DOM, and they are a little bit lighter, some of them, but in many cases, they don't support all the functionality, the entire feature set of DOM. So they usually are less, less complete. They are more limited, and they're non-standard. So meaning that if you use like JDOM, for example, or I don't even remember their names, but you can Google for them and you will find like different libraries. Let me check right now. XML, I'm Googling manipulation in Java libraries. There are, XML library support in Java. Let me check what we know about that. DOM4J, for example. JDOM, like I said, and some others. Anyway, they are still quite complex. So that was my first problem when I was thinking about Xambly, the library I'm going to introduce you now, is that I need something shorter. I need something more compact. That's one part of my one objective I had, is to create something which will be really lightweight, like really truly lightweight. And the second was that I wanted to create something which would be cross-platform, not only from Java to Java, but from Java to Ruby, from Java to PHP, it's something which would be supported potentially on any possible platform and would be language agnostic, so not specific for any language, but that would be applicable to all possible languages. Anyway, let me show you what I created, and then you will be able to judge me. So let's see how this small document could be created in Xambly. So Xambly is not just a library, but a language. So first of all, I introduced a language. I was saying to myself that in order to create an XML document, how about we structure our procedure of creating the document into commands, into operations, into directives. That's what I call them, directive. So in order to create the document which would look like this, like we just saw it, book, and then books. So in order to create the document of this structure, I would probably need to first I need to create books, and then I need to add book into it. And then probably if I want this book to have a name, so I would say Object Thinking here. You know this great book, right, by David West. And then I need to change the content of book to Object Thinking. So those are 3 operations which I want to do in order to create the document which we see here. 3 operations. And I decided to break it down into actually 3 operations, 3 commands, which we give to some engine, and then ask that engine to process them one by one, command by command, and return back what was created. So let's see how it works in action. We create a collection of directives. Here they are. It's a small class. You provide just a string. and say the command number 1 is add books. Well, you say add, there is no root element, so it will understand that the document is completely empty and the only place to add books is to make it the root element. And then the next command is add the book again, because we add books, so we create the first high-level document, and then high-level element, and then we stay at that element, and now it's time to add a new element, and we are located at the root, so it means in this case, the add command will understand that the book has to be added to the book. And then we need to set the content, object thinking. That's pretty much it. So this is command separated by a semicolon. Another command, another semicolon, and another command. So we have 3 commands, and they are like, it's like a language, you know, like a programming language. And that's why I called it assembly, to mark the assembly. You know, the language assembly, which was the oldest, which is actually the language right now for programming CPUs, for programming microchips, for programming controllers, for programming processors. And that language actually also has commands with attributes, with arguments. This is the command, this is the argument. This is the command, this is the argument. And the command may have a number of arguments, 1, 2, maybe 3. So the next step is that we give these directives to the assembler. The assembler, again, I mock the assembler. So we have the assembler and assembly, and here it's assembler, which takes the directives and then it can do something with them. So for example, I'm saying like .xml means produce the XML for me. So build it, not using anything, so not modifying anything, but produce it from scratch, like you have nothing. So apply my commands to nothing and then see what happens. And it returns the string. It returns just a plain string, and then we print that string. So let's run it. I'm in the unit test, so it has to work, I guess. Oops, we put some garbage in here. Once again, it has to work, I guess. Well, I tested it some time ago. Yeah, here it comes. You see? I don't know this red line of, I don't know what it means, some bug in my IntelliJ. So here's the document. That's the preamble of the document. Don't pay attention to it. It's for any XML document. And then goes books. You see it's properly formatted, so it is indented right. And there's a book, and that's the value of the book. You see how simple it is. So we actually give commands. We can make it more complex. So we can rewrite, for example, the content. You see this set is actually setting the value. I can change it. I can set it to elegant objects. Since we're still staying at the same document, at the same element after the set command. So the set command, if you run it again, it will just overwrite what was there. Let's try. I'm running it now. You see? So we have elegant objects here. We can add an attribute to the element where we're staying. And now I have to mention the cursor concept. So when we're modifying the document, when we're changing the XML document, we have the cursor, the position where we are located right now. So right now we're located at the element book, as you understand. So we're staying here at the book, at the last element we just added. So we're located at the book, and we can set the attribute. So I'm saying set me the attribute ID 123. That's another command which I'm giving to the processor, to the assembler. So now we should see the ID. You see, the ID is right here. That's the second command. Actually, assembly has, I think, up to 10 commands, so there are not so many. So let's see them all. Well, let's say I want to add another book. And then I have to use the command which is called up. So I'm staying right now at this element book. And I want to go up to the level of books. And then I want to add another book. So I jump to up, and then I say add book again. You see what's happening. So I'm jumping one level up because the document is hierarchical, as we discussed before. So the up command just moves me up to one level up to the parent element, and then I say add book. And now I will see another book. I guess. Yeah, you see the book is right here. It's empty. This syntax means that there's nothing inside this element and it's just empty. That's pretty much it of all the basic commands. There are some other more complex commands. For example, you may want to jump at some position of the document. Let's say you want to use XPath. XPath, as you know, most probably, is the language for XML, for defining the right place inside the XML element. It's really rich language by itself, where you can specify what you want to find. For example, I want to find the book which has the attribute ID equals to 1, 2, 3. I have to say it like this. Equals to 1, 2, 3. I think I need this. Yeah, I believe so. Yes. So I need to find the element, which is, first of all, I find the parent element books, then I find the book, and then I find the book which has the ID 1, 2, 3. So let's say here we added the book, and let's put another ID here just to make it different. 555, for example. So now we have two books with the ID 1, 2, 3 and with the ID 555. And now I want to find, now my cursor right now here is located at the second book, as you understand. So the first book we added, then we jumped up to the level of the books, to the parent level, and then we created a new book, and then we set the attribute, and now we're located at this second book. So now I want to jump to some arbitrary place of the document, some place where I can find through the XPath. So I specify the XPath, and I should be there at that particular book, at the book with the ID 1, 2, 3, and I want to add another attribute. No, you know what I want now? I want to remove it. Let's say I want to remove the first book. So let's set the content of the second book to Don Quixote. Did I write it Don Quixote? I don't know how to write that. Let's call it War and Peace. How many books do we know? War and Peace. So we have two books, Elegant Objects and War and Peace. And then we want to delete the book with the ID 1, 2, 3, which would be the Elegant Objects book. So first, before we delete, let's just run what we have now without deleting. Let's make sure that we have two books actually. I'm running now. Something is wrong. It says syntax exception. Syntax exception, missing semicolon. So it didn't find a semicolon somewhere. I guess the problem is with this 1, 2, 3. Let's just make it easier this way. Yeah. So we have two books. As you can see, book 1, 2, 3 and book 555. There are two books, two values. Everything looks cool. And now I want to delete the book 1, 2, 3. So I find it with the XPath, and then I say remove. Then I run it again. Boom, we have just one War and Peace. How simple is that, right? So all the manipulations with the XML document, you can just expose, you can just write in a simple language, which is understandable by humans, by people. Because if you write the same piece of functionality using DOM or any other library in Java, it's going to be at least 10 lines of code, which will be not so easy to understand in the future. I mean, it's going to be a lot of code. This language is understandable by any human being. There is also one instruction which I use very often. I call it, it's for validation of the instructions which I write. It's called strict. Strict 1. Why do I need this instruction? This one means that when you are at when you are at any specific position, at any place, just make sure that you are pointing at one element, because XPath may find you multiple elements. Because XPath doesn't necessarily point you to one element. It may point you to a number of elements. For example, I may say it like this. So find me all the books in this books parent. So go to books and then find me the book. And there are two. So in this case, we will have, let's put it back, let's run it right now and check that strict will say, yes, you are now pointing at one element only. Not two, not three, but one, only one. So let's run it and make sure that it actually passes, that we have the success. Yeah, it is successful, but if I remove this, now the XPath will point to two books, and strict will throw an exception and say like something is wrong and remove. That will prevent from the accidental removal of too many elements. So let's run it and see. I am expecting exception right now, the runtime exception. Yeah, you see it says two current nodes, books, book, books, book, while strictly one expected. So we get an exception which says what it says. So there are two nodes and we want just one. If I remove strict, if I remove this asserts, this validation command, then remove will delete two books. Let's run and see what happens. Now we should get an empty element, just books, just the parent element. See, we deleted everything. So XPath will find you what you're looking for, and then remove will just delete whatever you want. And if I say, instead of remove, I say, for example, set, let's say another book, Anna Karenina. And if I run it now, then what do you think will happen? You may be wrong, both books will be renamed. We're going to set this value to both XML elements. Let's run and see. I'm running now. See? Boom and boom. So my point is that the cursor, the place where we're pointing right now, may contain a number of elements, not just one. That's the way XML is designed. So you find, using the XPath, you find what you're looking for, you find the place to work with, and then you use any modifications. You modify what you want, and it's going to be applied to all elements at the current cursor. So this is basically what you need to know. There are a few more commands which you can read from the documentation, just a few more. So in total, that's pretty much it. That's all you need to manipulate, to build an XML document and modify the XML document. So when the XML document is coming in, for example, in this case, we're building the document from scratch, like it's an empty document. But we can as well modify a document which was built before. For example, let's go see the unit test, which does exactly that. Oh yeah, one more thing which I didn't say, that actually this library provides a more elegant way to write those directives. So you have a number of methods which you can use in order to, it's a fluent interface. So I can rewrite this code which I just written in actually Java, which is more convenient for, you see, I'm just rewriting the same stuff, but instead of a string, you can use set elegant objects, same stuff, but a fluent interface. Attribute, you got the idea, etc., etc., etc. It will do exactly the same. But in this case, of course, it's more convenient because you can provide here some value. I don't know, it's in Java. Now you're in the Java world. Instead of writing the text, you can write it this way. And what's interesting is that these directives, I'm just jumping to the next phase of our discussion, is that these directives can be converted to a string as well, and it can present itself. It can present itself as as a program for Xambler. So let's run it and see. You see, this is the program which we were writing before by hands, but now it is written by this instrument. Add books, set elegant objects, attribute, etc., etc. So the beauty of this language, where it can be used, and I'm gonna demonstrate you in a few minutes how it is used in a real application, is that it's a program, it's a piece of instructions which we can transfer over the network. We can work with this text as if it would be a program in Java or in Ruby or in PHP or in any other language. So it is, this set of instructions is transferable, and that's what makes it really convenient for multiple cases, and I'll show you which cases exactly. But before we jump in there, let me show you, as I wanted to, let me show you how you can modify the document. Not only create a new one, as we just did, but actually modify an existing one. So let me find it in the test, so we don't really for example, let's do it this way. I'm using another library of myself, which is called JCabbyXML, but it's not important now. So let's see. Let's say we have a document, and it's called books, and it's called book, War and Peace. Node. So let's say we have a node. This node is coming from, it's a DOM class, DOM interface. So it is pure native Java implementation of XML. And then I want to modify it. I want to replace this book with my own book. So what do? So here's the node, which is coming to me from somewhere. It doesn't matter. So don't pay attention to this class. It's coming from another library. The point is that in the end, we have a node. We have a document, an XML document with just two elements. This one parent element, and then it's a child element. And then I want to delete the book and insert my book there. So what do? First of all, I find the book there, and the location is this. I find it. Then I make sure that it's only one book there, so I don't delete something which is not intended to be deleted. And then I add my own book, and I set the title of this book, and I set the attribute. So now I run the assembler with my instructions, and I want to apply these changes to the node. So I say apply it to the node. So don't generate me the document, but actually use this set of instructions, set of directives, and apply them one by one to the node I'm giving you. And finally, again, don't pay attention to this. It actually converts the node to converts this object from DOM to string. So let's see how it works. So now we should, if everything works fine, we should delete that book and inject my book in there. Oh, you see what happened. Books, book, War and Peace, and then boom, something wrong goes on. I can tell you what's going on. We did not delete. So I forgot the command remove. And see what happened. It found the book, and then after the text content, it injected my book in here. So the result element is kind of messy, the result XML. It's not what I wanted. So let's run it again with the remove command, with the remove instruction. See, it's all cool. So we actually modified the document the way we wanted to modify. Try to write the same code, but in DOM or in any other library for Java. That will take a lot of lines of code, and it's going to be pretty messy. You will run XPath. That will be difficult. So now it's easy, and it's easy to understand. You know, the first instruction, find the place, make sure it's just one place, remove it, add the book, set, and add goes to the element where we're staying now. And remove, of course, it removes the element at the cursor and jumps one level up to the parent place, of course. So we're at the parent, so we can add the book and set the title, set the attribute, and etc., etc. And we modify the document. So you can create documents, you can modify documents. You cannot read documents. So Xambly is not for reading at all. So Xambly is just to modify documents, to create them, to modify, to work with them, to make changes. If you want to read, then you need XPath, you need something else, you need another library. And this one is only for making changes, for correcting the XML document. I think that's pretty much for the feature set of this stuff. There are a few other instructions like namespace, for example, which you may need in your code, maybe not. Some people don't use namespaces. And of course, the library takes care of all the escaping of the code. For example, I can say elegant objects, something like that. And you know that, sorry, it's the wrong price. So I can say something like that. And you know that inside XML, you're not allowed to use these symbols because they are reserved for XML. So if you just set it like this and use it inside, then you're going to break the structure. So let's see what the library will do. The library will understand that these two symbols, they have to be replaced, escaped, so-called. So you see they replace it with this, how they call them, I don't know what's the right, I forgot the right name for this, for the symbols that go after the ampersand. So the library takes care of everything you need to take care of when dealing with. There's also one command called CData. I tried it today, and it is supposed to generate CData block for the XML. Let's try it again. Yeah, it's still the same, but the CData will potentially, it's for larger pieces of text. Anyway, so let me demonstrate you how it works on a larger scale, a big application. So let me show you the code from another library, from another product, which is called Rulter. Let me switch the window now. Here it comes. So I have a project, a Rulter called Rulter.com. It's a DevOps assistant, which we use in so many projects of ours, which helps us deploy stuff and merge stuff. It's a chatbot for GitHub. It listens to your commands on chatbot and then reacts to the commands and then does something for you, like starts Docker container, builds stuff for you, builds your stuff for you, deploy it, release it, and so on and so on. You can read about it. This is the source code. It's an open source tool, so it's a source code. And it is designed as a collection of agents. So there are many classes, small classes. Each of them is responsible for something that agent is supposed to do with the particular conversation with the client. So the client starts the conversation and says, I want this Docker container to run and I want these commands to be executed. And then we start agent by agent. And we ask those agents to do something in real world, like go to the server, start Docker container, or kill Docker container, or collect logs, or do something real. And then in return, we don't want those agents to tell us the result in just one line or just one number. We need those agents to be able to report their results to the XML document. So we have an XML document which includes all the information about this particular conversation with the client. And the more the client talks to us, the more information we collect in the XML document. And then we start an agent and say, hey, here's the document for you, the XML. It has some information. So now do what you're gonna do. And the agent, for example, goes to the server and starts a Docker container, and it has some information about the Docker container, like the Docker container ID, or the time when it was started, or the size of the Docker container. So it has to put that information somewhere, and we wanted to put it back to the document where everything happened. And we don't want it to modify the document, every agent to modify the document by itself. We allow them to return us back Xambly instructions which are potentially applicable to the XML document you started from. So you as an agent, you start with something. Let me show you. For example, so you start with something like this one. It's too complex. It's too complex too. I'm trying to find something simple. No, that one. Not this one. No, they're all complex. So let me find something really, really simple for you. Yeah, for example, this one. So we're like, pay attention to this method. So we call, this is an agent. This is the small agent. This is the size of it. Look, it's just all we have. So it's like one method. The entire class is right in front of you. That's the constructor and that's the method. So we call this method process. Somebody will call it for you, and it will give you the XML document as a full information about what's going on in the conversation. And then you do something with this document. Look, you're trying to find something, some ID from there, you get it, you do some manipulation, it's up to you. And what you return back to us is that you return a collection of assembly directives. So you tell us back what needs to be done with this document, how do we need to modify it in order to, to transfer it later to some other agents. So your work as an agent is the result of your work is a collection of instructions for the XML document, which we apply, and the document changes. And here's how we generate it. Look, you find the location, you know the commands already. You add some shell element, then you set the attribute, you add the host, you set the value of the host, you go up, you add the port, you set the value, you go up, you add logging, you add key, and that's it. And then this stuff is returned. So those who's going to call the agent, they just give you the XML document and say, work with it. So it's like a micro database. So we're giving you like a small, local XML database. And then we don't ask you to modify it. You don't need to modify it yourself. You don't need to run assembler. You just return us the instructions, and then we know how to modify it. We know how to synchronize those modifications. We know how to work with them. It's basically like a SQL instructions, like SQL for relational databases. So you return back the program in assembly, in imperative language, which contains commands one by one, and we later, our engine, applies those commands to the actual database, to the actual storage. Why it's better, why it's good, why this design, why this architecture is good, is why did I introduce that architecture years ago, is that in this case I can perfectly decouple agents from the implementation of the database. So those agents, they don't know anything about how the XML documents are being stored. They have no idea how they are synchronized. They have no idea how exactly they are modified. All they know is that there's information coming in an XML document, and they can suggest some modifications. And those modifications are suggested in the language, which is assembly. That's the design. I think that's pretty much it. That's all I wanted to say. Let me check your questions. There's one question: can I make the next webinar about exceptions in Java? Well, I can probably, yeah. Exceptions is an important point. We may talk about exceptions sometime later. And let me see maybe some other questions you may have. Yeah, there is a question about with the /n. Let me try with the new line. Yeah, that's what you're asking about. So let me switch the screen back again. Here it is. This is assembly. So let's put here. I think it will just put the new line in the XML. So let's run. I'm sure. It's going to be two lines, elegant objects, and then new line and the dollar amount. You see? So it says elegant objects and then /n and then this stuff. So that's the way it is. Actually, it produces the XML document, which is uh, which is valid, which is parsable, which can be validated by any XML validator, and it will be okay. Let's try, yeah, and set C data. You see, it doesn't matter. Set C data, whatever. I can't remember right now what's the difference of the C data. You can, but this method was introduced by myself. So that's /n. You can put /r, and let's see what happens in this case. I think /r will be actually translated to this ampersand command. Yeah, here it comes. You see, so it actually escapes that text. So that's it. I actually recommend you to use this Xambly in as many places as you have to deal with XML. Just use Xambly. I do it every time. I even forgot how to deal with DOM like many years ago. In all my projects, I need to use XML. Xambly it is. It's really lightweight. It's a small library. It doesn't have any dependencies. No dependencies at all. Or maybe I'm lying. Yeah, I'm lying. It depends on the Antler 4, but that's something I'm thinking about removing for many years already. So if you want to contribute, you can join this GitHub project and actually help me get rid of Antler, because this text, which is a program in Xambly, needs to be parsed. But it's really simple syntax. But I'm using Antler right now, just real syntax parser, which seems to be an overkill because it introduces a dependency. It's a quite large library, has to be inside, and it's not really required. So it could be done in a lighter way, in way simpler way. So if you want to contribute, you can join in. There's a ticket for that, hanging in there for like 4 years or something, and you can help me refactor it. What else is good here? It actually configures everything right for you. It deals. It actually is a wrapper on top of DOM. So there is no magic inside. So I don't deal directly with XML manipulations. I use DOM. I use real proper DOM. You can see, like, for example, how this add command is implemented here. Here it is. So I'm using DOM. So I'm actually, creating elements. I'm appending child. So I'm using the normal, real, standard Java implementation for XML manipulations. But I decorated with a way better syntax, way simpler, and way more effective. Some may call it a domain-specific language, like a DSL. This quite popular name right now. So Xambly could be called a DSL. It's a domain-specific language. It's a language specifically designed to manipulate XML, and it is quite effective. Even though I'm not a big fan of DSLs, because I think in most cases they introduce confusion, because it's a unique syntax, a specific syntax which somebody who's going to use it need to learn, and it takes time. So if I'm the Java developer and I jump into a project where Xambly is used, then it will take me some time to understand what it is, to learn that language, and before I can start using it. But if the language is really simple, like this one, and it actually makes your life easier because it's simpler, it's more simple than something that it decorates, then it does make sense. Like in this case, it does make sense to use Xambly. That's the entire library. Look, it's not that large. It's pretty much covered by by tests. It's well written, even though it's 6 years old. So I recommend you using it. That's all I wanted to say. Yes, it is. That's a good question. It is imperative. It's not declared. Well, it is imperative in the way it works, but it is declarative in the way you suggest modifications to the XML. Like, for example, SQL, the language for manipulating relational data. Is it imperative or declarative? Well, it is declarative, yes. You just declare the result. You say select something for, and then blah, 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 and then you declare the result. But there are, some modifications to SQL which actually allow you to define variables and to actually run a number of instructions and then insert something there. You not only select, you may insert, you may update, and then if you update, select, insert, update, then the collection of these commands, it does sound imperative because you're telling the server what to do. But this entire piece of code, this entire program in SQL, it is actually quite declarative because you're not directly telling the server which database, which file to open, which which table to lock and which table to unlock, even though you can do that. But it's more like you declare your intention. You say, I want that piece of modifications, these pieces, this set of modifications to happen to my database. The same for assembly. So you declare your intention and you say, I want these 15 modifications to be made to my XML document. The same here. So anyway, my dear listeners, thanks for coming. I imagine it's a summertime for you, or maybe the subject is quite narrow, so we got like less than 100 viewers today, even though usually we have more. So I guess I see you next time. I'm trying to organize these webinars every month, the first Wednesday of every month. The update from me, what I'm working on right now, I'm working hard on this Junior Objects book. I told you about that, I think, last time, that it's going to be a book for junior developers who just want to learn object-oriented programming. And I'm working on that book. It appeared to be quite easy on the first part, and now it's a second part, which takes longer, which actually needs more thinking on my side. So stay tuned. The book is going to be published quite soon. Thanks for listening. See you next time. See you next month. Bye bye.